Hi children, good morning. Today we shall solve the problems of exercise 3.3 of a polynomials chapter class 10. Today we are going to solve 1 and 2 bits from first question. What is the first question? Find the zeros of the following quadratic polynomials and verify the relationship between the zeros and the coefficients. So what does this question meaning? First we need to find zeros of these given polynomials and next we need to verify the relationship between the zeros and the coefficients. If you see here all these polynomials in the quadratic polynomial, what is the highest power of these variables? 2. 2 is the highest power of these variables. So these are all in the form of quadratic polynomial. Now move on to first problem, that is x square minus 2x minus 8. X square minus 2x minus 8. It is in the form of quadratic polynomial. What is the general form of quadratic polynomial? Ax square plus bx plus c. Here a is the coefficient of x square, b is the coefficient of x, c is the constant. Now you need to understand what is the relationship between zeros and the coefficients. Okay, you need to understand what is the relationship between the zeros and the coefficients. For suppose by factorizing this quadratic polynomial, we will get two zeros. Okay, for suppose that two zeros are alpha and beta. When you add these two zeros, you will get the answer same as by taking minus of coefficient of x, that is b, divided by coefficient of x square, that is a, minus b by a. When you multiply those two zeros or the product of two zeros alpha beta is equal to, means you will get the same answer as constant term, that is c, divided by coefficient of x square a. This is the relationship between zeros and coefficients of the polynomials. Okay. So now compare this given polynomial with quadratic polynomial. With general form of quadratic polynomial ax square plus bx plus c. Here a is coefficient of x square, that is 1. Here there is no value. Here 1 into x square equal to x square. There is no value, means that is 1. A equal to 1. Here b is coefficient of x, that is minus 2. Here c is constant term, that is minus 8. So a equal to 1, b equal to minus 2, c equal to minus 8. Okay. So first we need to find zeros of this given polynomial. How can we find? By splitting this middle term. Into two terms. So I am doing here minus 2x minus 8. So by splitting this middle term into two terms. So how can we find these two terms? We have to take product of this coefficient of x square and minus 8. So x square into minus 8 equal to minus 8x square. So what are the factors of 8? 4 2s are 8 and 8 1s also 8. Okay. So 4 2s are 8, 8 1s are 8. This is one pair, this is one pair. We have two pairs. So if you add these two terms, you have to get this middle term. Okay. If you multiply these two terms, you have to get minus 8x square. For suppose if you take 8 and 1, if you add 8 plus 1 equal to 7, will you get minus 2x? No. So we can't take 8 and 1. So now let us check 4 and 2. So first here we have x square, write 1x for 4, write 1x for 2. So here minus, here also in middle term minus 2x, here minus 2. So now put minus symbol for bigger number. Okay. For bigger number it has positive symbol, put the positive symbol. Okay. So if you add minus 4x plus 2x, what will you get? Minus 2x. Okay. You will get the same, minus 2x. If you multiply minus 4x into 2x, minus 4 into 2, minus 8, x into x, x square. So you will get the minus 8x square. So now we can write it minus 2x as minus 4x plus 2x. So x square minus 2x we can write it as minus 4x plus 2x and constant term that is minus 8. So see here, these two terms as 1 pi, these two terms as 1 pi. In these two terms I am taking x as common. Here x into x square, when x is common we have left with 1x, that 1x minus, here x is common we have left with the 4. Okay, close the bracket, and now plus 2x minus 8. Here I am taking 2 is common. If 2 is common we have left with the x, and in between we have minus, put minus. 8 in 2 table 4 times, 2 4s are 8. Okay, see again, here plus, in between you have plus, plus 2 is common, I am taking here plus 2. If you see here, here plus c is separate these two terms. Okay, in these two terms again x minus 4 is common. X minus 4 is common. After taking x minus 4 is common, we have left with x plus 2. X plus 2. So to find the zeros, we have to equate each of these equal to 0. X minus 4 equal to 0 and x plus 2 is also 0. X equal to 4, x equal to minus 2. So these are minus 2 and 4 are the zeros of this given polynomial. Minus 2 and 4 are the zeros of the given polynomial P of x. Okay, now we need to verify the relationship between zeros and coefficients of the polynomial. So verifying relationship between the zeros and coefficients of the terms. Okay, so here let us assume alpha equal to minus 2 and beta equal to 4. Alpha equal to minus 2 and beta equal to 4. So sum of the zeros alpha plus beta equal to minus b by a. So first check sum of the zeros. What is the alpha value? Minus 2. Plus what is the beta value? 4. So minus 2 plus 4 is equal to 2. So subtract 2 from 4, we will get 2 equal to minus b by a. So what is the b value? So what is the b value? Minus of b value is minus 2 divided by a. A value is 1. So minus into minus plus 2 by 1 is equal to 2. So when you add these two zeros, you will get 2. Okay, minus b by is also 2. So we can say alpha plus beta equal to minus b by a. Okay. Now product of two zeros. Product of two zeros. Alpha beta equal to c by a. The relation is c by a. Now we need to check what is the alpha value. Minus 2. Beta value is 4. Equal to what is the c value? Minus 8. Next divided by what is the a value? 1. So minus 2 into 4. 2 4s are 8, minus 8. Here minus 8 divided by 1 is nothing but minus 8. So it is also proved alpha into beta equal to c by a. This is the relationship between zeros and coefficients of the terms. Now move on to second problem, that is 4s square minus 4s plus 1. Okay, comparing this given polynomial with the general form of quadratic polynomial. Comparing given polynomial with quadratic comparing given polynomial with the general form of quadratic polynomial, that is ax square plus bx plus c. So what is the coefficient of x square? A is nothing but a equal to 4 and b equal to coefficient of s. B equal to coefficient of s, that is minus 4, and the constant term c is constant term, that is 1. Okay. Now we need to find zeros of this polynomial. So we have 4s square minus 4s plus 1. So find the zeros of this given polynomial. How? We need to split this middle term into two terms. Here minus 4, we need to split this two middle term into two terms. How can we find these two terms? By taking product of 4s square into 1. 1 into 4s square equal to 4s square. What are the factors of 4s square? 4 ones are 2 twos. So we have the factors are 4 and 1 are 2 and 2. Suppose if you add these two, you have to get this middle term minus 4s. Okay, you have to multiply these two terms, you have to get 4s square. Suppose if you take this pair, if you add these two, 4 plus 1 equal to 5. But we have to get minus 4s. So this pair is not possible. So if you take 2 and 2, here s square, write 1s for this, write 1s for this. So here minus, you have to keep minus for these two terms. Minus 2s equal to minus 4s. Okay, minus 2s, adding these two terms, minus 2s plus of minus 2s equal to minus 4s. So here we will get this middle term. When you multiply minus 2s into minus 2s, minus into minus, plus 2 into 2, 4, s into s square. So when you multiply these two terms, you have to get 4s square. Okay. So now we can write it in place of minus 4 plus 4s, minus 2s and minus 2s. So 4s square minus 4s, we can write it as minus 2s and minus 2s plus 1. Okay. Here 4s square and minus 2 as one pair, minus 2s plus 1 is a one pair. In these two terms, 2s is common. After taking 2s, we have left with 2s. Here minus, keep minus, 2s is common, we have left with 1. Okay. Here I am taking minus 1 is common. Then we have left with 2s and minus 1. Okay, we can write it as plus 1 minus 1 into minus 1. Here 1 minus 1 is common. We have left with 1 minus 1. Okay. Again in these two terms, 2s minus 1 is common. I am taking 2s minus 1 is common. Then we have left with 2s minus 1. So to find the zeros, equate each of them is equal to 0. 2s minus 1 equal to 0 and 2s minus 1 equal to 0. Here s equal to 1 by 2. Here also s equal to 1 by 2. These are the zeros of this given polynomial. Let us assume alpha equal to 1 by 2, beta equal to 1 by 2. Now we need to verify these zeros with the coefficients of the terms. So verifying relationship between the zeros and coefficients. So what are the relationships we have? Sum of the zeros equal to minus b by a. Sum of the zeros are alpha plus beta. Alpha plus beta equal to minus b by a. So this is the first case. So what is the alpha value? 1 by 2. Plus what is the beta value? 1 by 2 equal to, Here see what is the b value here? Minus 4. All minus b by a. First keep this minus and b value is minus 4 divided by a value is 4. Minus into minus plus and 4 will get cancelled. So 1. Okay. So 1 by 2 plus 1 by 2. Here denominators are same. Just simply add the numerators of these two fractions. 1 plus 1. 2 by 2 equal to 1. 2 by 2 get cancelled. We have left with 1 equal to 1. So we can say alpha plus beta equal to minus b by a. Now we need to check second case product of the zeros. Product of two zeros. Alpha beta equal to c by a. Okay, what is the alpha value? 1 by 2 into beta value is 1 by 2 equal to what is the c value? 1 divided by what is the a value? 4. So 1 by 2 into 1 by 2, multiply numerators 1 into 1 1 divided by and multiply these denominators 2 into 2 2 2 are 4. 1 by 4 equal to 1 by 4. So again we have proved alpha beta equal to c by a. Thank you for watching.